In section 9.6, we're going to be asking the same question we've had in the last two sections, which is how do I solve a quadratic equation? And let's actually pause for a second here and go down and fill in this part over here, where it says list the two main ways we already have of solving a quadratic equation. Remember, quadratic equation looks like ax squared plus bx plus c is equal to 0. And algebraically, we're looking for what x values give us a 0 out. Graphically, remember when you're looking for the x values that give you a 0 out, you're looking for these x-intercepts right here, like at 2, 0, and negative 3, 0. And we've already had two ways, actually we've had three. We're not going to do it by graphing because we said that can be kind of inaccurate and time consuming, but we did have two other methods, and one was called by using square roots. We'll discuss the weakness of that in a moment. And the other way was by factoring and using what we call the zero product property, but basically by factoring. And we're going to get a third way today. But again, before I finish off that essential question, we've already got two ways, and let's discuss why we even need a third way. And it's because these ways up here each have a weakness. The weakness of using square roots is that it only works in a situation like this, where there's no what we call b term, because I can attack that x, for example right here, by adding 1, dividing by 2, and taking a square root. And so I can just use an algebraic approach. Factoring is great when there is that b term, because I can just break it up and say, well, that's x plus 3 times x plus 5, and I can factor it. And I can say, well, then x would have to be negative 3, or x can be negative 5. But the weakness of factoring is that not all quadratic equations are factorable. For example, had this been a 14 right here, then it doesn't factor. And it's got a b term, so this method fails me. And graphing would be inaccurate because it's going to be a decimal. So we need a third way. And that third way, that is, how do I solve a quadratic equation by using what we call the quadratic formula. So there's a big formula that gets its name from the fact that it's used for solving a quadratic equation. It's in the top 10, I would say, of all things you learn in your algebra career. So let's go fill this in. And I would tell you that the quadratic formula is the most powerful. Notice I didn't say the best. I didn't say the easiest, the fastest. I said it's the most powerful method of the four. Remember, the first was graphing. Didn't really like it. It's time consuming and not accurate. The second was square roots. Loved it, but it doesn't work when there's a b term. Third method was factoring. Not so bad, but what if it doesn't factor? So this is what makes the quadratic formula so powerful, is that it always works. There is not a quadratic equation where you use the quadratic formula and you don't arrive at the correct answer. Then that bodes the question, well, why don't we just learn the one way? And you'll see that when we start using the quadratic formula, it's pretty labor intensive. It takes a while. You've got to be really careful with it. And so if any of the other three methods work, we choose those first because they're quicker. So the solutions to a quadratic equation, now a fourth way, can be found by this formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. And this formula we're going to use like a map. And in class I sung it to the tune of Pop Goes a Weasel, but I'm not going to do that on video. So again, it's important to note, just like with the other methods, that usually we get two answers. Even when we factored it, we usually got 2. When we did our square root method up here, we would say add 1, 2x squared is equal to 50. We end up getting x squared is equal to 25, and we say x is plus or minus 5. Usually we have two solutions because we say what goes up is going to come back down and hit it. Likewise, if it opened up, we get two solutions, or two x-intercepts. But it's also possible for there to be one solution, and we have to discuss what happens with the quadratic formula when there's just one solution. It's also possible that there are no solutions. And I'm going to briefly, you'll discuss in more detail in Algebra 2, you'll discuss what happens with these. But notice, two solutions because it hits twice, one solution because it hits only once, and no solutions because it never hits. Well, what would that look like in my formula? You'll notice in the formula there's this plus or minus, and that's what gives you two solutions. Let me give you an example of what would happen with that. Suppose it was -2 and you had plus or minus, and you ended up with a 25 down here. Maybe it's all over 4. You're going to branch off and get two answers. One where you go up 5 and one where you go down 5, and you're going to end up with two solutions. What happens with this one is that you end up under the root getting a 0. And so what basically happens is when you go up 0 and down 0, you end up at the same spot. Hence, you only get one solution popping out. What happens over here when you solve the quadratic formula is you end up with a negative under the root. Doesn't matter what it is, but if it's negatives, we can't root negatives, which means there's no solutions. So you'll notice that it's what's under this root kind of tells us how many solutions we're going to get. If it's positive, we get two solutions where we go up and then down. If it's 0, we get only one solution because when you go up 0 and down 0, you end up at the same spot. When there's a negative under the root, you actually get no solutions. Now this situation is kind of your favorite one because you get to quit right there. The minute you realize you're rooting a negative, you get to stop and say no solutions. In the other two scenarios, you got to keep going and tell me what the solutions are. So let's go try this. We've got two of them that we're going to do today. And the first one is x squared minus 4x equals -4. This isn't in standard form though, so we need to get, just like with the other ones, we need to get it equal to 0 before we start. So I've got x squared minus 4x, plus 4 is equal to 0. My quadratic formula requires me to pluck off these coefficients, and I want you to do that off on the side. A would be a 1, ax squared. B would be a -4, bx. C would be the positive 4, so ax squared, bx, c. You need to pluck those off because those are going into your formula. Your formula, if you forgot it, look on the previous page. It's x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And formulas are nice because you follow them like a map. But also like a map, if you make one wrong turn, you're going to be going the wrong direction. So we really have to make sure that when we plug these numbers in to the map, we're careful. For example, it leads with -b. And a -4 is actually positive. So I actually even like to say that this is the opposite of b. So that's been plugged in. Then the map says I do plus or minus. Then it says I do a square root. Under the square root, I'm supposed to do b squared. Do that in your head. B squared would be 16. -4 times -4. If you enter it on your calculator, if you don't put parentheses, it's going to give you a -16. So it's b squared minus 4, and then I like to use parentheses in this for the a and the c. A is 1, and c is 4. And then it's all over 2 times a. In this case, it'd be 2 times 1, which is just 2. Now what I do next in the quadratic formula is I go under the root, and I like to clean that up under there. Under that root, I've got 16 minus 4 times 1 times 4, which is another 16, which means under that root, I've got a 0. And I'm going to rewrite it. The It's really 4 plus or minus the square root of 0 over 2. At this point, I take this root. If it was a 25, I'd replace it with a 5. If it was a 4, I'd replace it with a 2. If it was an 11, I'd go to my calculator and have to round it. But this is a 0, so I get 4 plus or minus 0 all over 2. At this point in the quadratic formula process, you branch off, because it says you need to do plus and you need to do minus. So we're going to do 4 plus 0, which is 4, divided by 2, which is 2. And then we're going to do 4 minus 0, which is 4. And you'll notice I got the same answer here twice because I had that 0 under the root. And when I went up 0 and down 0, I ended up with the same answer. So this has got one answer of 2. What that means is, had I graphed the parabola, it would have hit once at 2. All right, so let's go to the next one. The next one, again, we start by getting it equal to 0, which it already is. We identify our A, we identify our B, we identify our C. Then we take out our map. If we forgot it, we go look. It's x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And I go in and take each one of these and plug them in to the map. X equals opposite of b, which would be negative 2, plus or minus the square root of b squared, which is 4, minus 4 times a, which is 1, times c, which is 5, all over 2 times a. Then we immediately go under the root, because the root controls the rest of the work, and you evaluate that. That's 4 minus 4 times 1 times 5 is 20. 4 minus 20 is a negative 16. The minute I get that negative under the root, I can't root negative numbers, so there's no way I can go on with this problem. And what it means is that there are no solutions. So no solutions to this one. And by the way, had I graphed this, it would have looked like, we kind of know what it's going to look like. It opens up. It's got a vertex at negative b over 2a, which actually puts it at negative 1. It also puts it actually, if you were to graph it, it's going to look something like this, and it's never ever going to hit this x-axis. So that's how you use the quadratic formula, and we'll be doing some more of that in the next video and some more of it tomorrow with some more detailed problems. So make sure you watch 9.6b as well. Have a good night.